Hi everyone, welcome to the Mathemagic channel. Today we look at a question from AMC10 2022. This is question 11. Looks a little bit spicy. Let's jump right in. Okay, welcome back. So the few things to notice here is that on the left hand side we have 2 to the power m, so the variable is a power, and on the right hand side we have 2 times the mth root. So you see this root with an m on top, that's the mth root. Now roots can be expressed as powers as well, so I guess we can mix those together at some stage. Also worth noting that 4096 is a power of 2, so 4096 is actually 2 to the power 12, and that is because 2 to the power 10 is 1024. And so if you're doing Math Olympiads, you should probably know your powers of 2. So 2 to the power 10 is 1024 and 2 to the 12 is 4096. So with that in mind, we can think about what's going on the left hand side and what's going on the right hand side. We can also notice that since the 4096 is placed at the bottom, we can express it as 1 over 4096 equal 2 to the negative 12, because negative powers mean inverse. And so if we wanted to bring this power up to the top, we should express it as a negative power. Another thing to notice here is the mth power on the right hand side. So if you have a to the mth root, this is actually equal to a to the power 1 over m. And this is going to be relevant here as well. And so using all these facts, we can start rearranging the expression. We can also note that on the left hand side we have the square root, which means to the power a half. So if you have just the square root of a, this will just be a to the power a half. So with all this information, we can proceed with this question. So we'll have on the left here 2 to the power m, so 2 to the power m times the square root. So we're going to say that that's going to be to the power a half. But first we can say 2 to the negative 12, and then this expression to the power a half. Now remember that this is because it's a square root. And then on the right hand side, we can say 2 and then times the mth root. So the mth root is going to be to the power 1 over m of 2 to the negative 12. So 2 to the negative 12, and then this is to the power 1 over m. And now we need to use another rule here, noticing that when you use exponents and you have to the power, you can say that a to the power m to the power n gets multiplied and becomes a to the power mn. We can use that for both the left hand side and the right hand side. And so on the left hand side, we're going to have 2 to the power m times 2 to the power negative 6, because minus 12 times a half, or a half of negative 12, is negative 6. And so on the right hand side, we'll have 2 times 2 to the power negative 12 to the power 1 over m. And using the same rule here, negative 12 times 1 over m is going to be negative 12 divided by m. And so now we've got everything expressed as powers of 2. We still need to do one more thing here, which is add the powers. And we can do that saying that a to the power m times a to the power n is equal to a to the power m plus n. So we can add the powers. So using this rule on the left hand side, we get 2 to the power m plus negative 6, which means 2 to the m minus 6. And on the right hand side, not forgetting that we have 2 to the power 1 here, we have 2 to the power 1 minus 12 over m. Now since both the left hand side and the right hand side are powers of 2, we can equate the powers, and we can just say that m minus 6 is equal to 1 minus 12 over m. And this is starting to look a lot like something that we can solve. If we multiply both sides by m to get rid of this denominator here, we're going to get m squared minus 6m is equal to m minus 12. Moving all the quantities to the left hand side, we can say that m squared minus 6m minus m will be minus 7m, and then minus 12 moving to the left will become plus 12, that this is going to be equal to 0. And so this is a quadratic which is relatively simple to factorize. You look at factors of 12, which add up to negative 7. you probably find the factor pair -3 and -4 quite easily. And so -3 times -4 is going to be equal to 12, and -3 minus 4 is -7. So this quadratic factorizes as m minus 3, factor of m minus 4, equals 0, which would lead you to think that m is equal to 3 or m is equal to 4. Now both of these values are true, and so we need to find the sum here, which means that we need to add these two. So one answer is 3, one answer is 4, so both of these values are positive and make the equation true, but the answer is going to be, so don't forget to add at the end 3 plus 4, and the answer to the problem is actually going to be 7. And 7 is the right answer for this. Since you're doing Math Olympiads, it could have been worth noting also, if you wanted to go slightly faster and you were pressed for time and did not want to complete this quadratic, that since we're looking for the sum of all the numbers for which this is true, and there's 2 numbers for which this is true, we could have just used Vieta's formula instead of doing the quadratic. And Vieta's formula would have suggested that if you use minus b over a, so minus b over a in this case, which is going to be equal to minus 7 divided by 1, so just simply 7, well, minus b over a is the sum of the roots. And Vieta's formula will tell you that the sum of the roots is equal to minus b over a. And in this case, that could have been useful and saved you all of the quadratic steps. Not that they take very long, but it's just interesting to note, since you're doing Olympiads, that the sum of the roots is given to you by minus b over a, and you also have a formula for the product of the roots. Wow, what a beautiful question. Thanks all for watching this video. Make sure that you subscribe to support the channel so that we can give you access to more exclusive videos covering AMC Olympiad content. See you on the next one.